A 1,000-ton block of stone sits perfectly placed in an ancient temple. Modern engineering would struggle to lift it, yet our ancestors did it with no cranes or engines. This is the enigma of lost ancient technology, a puzzle that forces us to rewrite what we think we know about history. By the end of this exploration, you will see the past not as a primitive stepping stone, but as a landscape filled with sophisticated knowledge we have yet to rediscover. We will investigate how stones heavier than jumbo jets were moved across continents, and why entire systems of innovation might have vanished from our records. What do you believe is the true limit of human ingenuity? That gap between what we see and what we believe possible is the heart of the mystery. Stand before the great stones of Baalbek in Lebanon, and you are not just looking at a wall, you are confronting a question carved in granite. One single block there, known as the Stone of the Pregnant Woman, weighs over 1,000 tons. To put that into a perspective you can feel, that is heavier than 2 fully loaded jumbo jets. And it is not alone. From the multi-ton granite slabs lifted high into the Great Pyramid's burial chamber, to the interlocking walls of Sacsayhuaman in Peru, where stones fit together so tightly a razor blade cannot slip between them, our planet is dotted with these impossible feats. The conventional story tells us of copper chisels, wooden sledges, and ramps made of sand. But if you have ever tried to push a car out of mud, you understand friction, you understand weight. The idea of moving a 1,000-ton block, even a few inches, with those basic tools feels less like a historical account and more like a physical contradiction. Archaeologists like Dr. Mark Lehner, who has spent decades at Giza, openly acknowledge this puzzle. He notes that while we have theories, ramps, levers, water lubrication, the exact methods for the largest stones remain educated guesses. This is not a fringe mystery. It is a central, unresolved question at the very foundation of mainstream archaeology. So we must ask, not with skepticism but with genuine curiosity, what does this gap mean? If the tools we attribute to them seem insufficient for the task we witness, does it force us to reconsider the tools, or perhaps to reconsider the ingenuity of the people wielding them? This is where our search for lost technology truly begins, not in wild speculation, but in the sobering shadow of these colossal achievements. That physical contradiction is etched into the very earth in places like the granite quarries of Aswan, Egypt. Here lies a monumental clue known as the unfinished obelisk. Had it been completed, it would have been the largest single piece of stone ever carved by human hands, stretching taller than a 10-story building and weighing an estimated 1,200 tons. But a flaw in the bedrock caused a catastrophic crack, and the project was abandoned. This failure is actually our greatest window into their ambition. The obelisk remains partly attached to the living rock, its sides perfectly carved, its shape defined. You can still see the precise channels cut around it by workers using simple stone pounders. This tells us two things simultaneously. First, they possessed the incredible patience and skill to shape such a monolith using basic tools. But second, and more perplexing, it reveals a staggering confidence. They began carving this titanic object with the absolute certainty they could extract it, transport it over land and river, and erect it vertically in a temple hundreds of miles away. The planning alone implies a mastery of logistics we rarely attribute to the ancient world. The real mystery is not the carving, but what they intended to do next. How do you move a stone that weighs as much as 250 elephants? The conventional answer is ramps. Yet for a stone of this size, the ramp required would have been a colossal construction project in itself, made of millions of tons of brick and earth, sloping at a gentle angle for miles. Archaeologists have found evidence for smaller ramps at Giza, but nothing on the scale needed for the truly monstrous blocks. Then there is the problem of friction. Placing a 1,000-ton block on a wooden sledge, even on lubricated tracks, creates unimaginable resistance. The force needed to initiate movement would likely crush the wooden runners into pulp. Experiments with smaller replicas show it is possible, but scaling that physics up to 1,000 tons enters a realm of diminishing returns, where the solution becomes more massive and complex than the problem itself. Look at the famous Moai statues of Easter Island. These are not just heads but full bodies, some weighing over 80 tons, carved from volcanic rock inland, and then transported miles across rugged terrain to the coast. The island's oral traditions speak of the statues walking to their platforms. Researchers have demonstrated that a walking motion using ropes is plausible, but again, scaling that idea to the multi-hundred-ton stones of Baalbek or Aswan seems to defy the limits of material strength. The tool marks and quarry sites are the fingerprints left at the scene, and they tell a story of a goal achieved, but with the method still missing from the narrative. The stones were clearly cut, they were clearly moved, and they were clearly placed with breathtaking precision. The evidence of what was accomplished stands in silent contrast to the simplicity of the tools we have found. This gap is our first solid clue. It forces a question that is both humble and revolutionary. Could it be that we have been looking for the wrong kind of tools altogether? What if the technology was not in the chisel or the hammer, but in a forgotten understanding of the material world itself, a way of working with stone that made it somehow? Less stubborn, the fingerprints at the quarry point to a process, but perhaps we have misunderstood the material itself. What if the stone was not always as hard or as heavy as it is today? This leads us to a second, more enigmatic clue, found not in the size of the blocks but in their very substance. At certain ancient sites, from the forts of Scotland to the foundations in South America, there are stones that appear to have been melted. Their surfaces are fused and glassy, a state known as vitrification. This is not a natural weathering pattern. It is the result of intense, sustained heat, the kind that transforms solid rock into a liquid. The conventional explanation points to massive, deliberate fires set against fortress walls, but the scale and consistency of the effect leaves many questions. Could this be evidence of a controlled application of heat, a technology to soften stone for shaping or even to fuse separate blocks together? This idea opens a door to a radical possibility, championed by materials scientists like Joseph Davidovits. He proposed that the massive limestone blocks of the Great Pyramid might not be carved at all, but cast like modern concrete. His analysis suggests the stone contains chemical compounds and air bubbles not typical of natural limestone, hinting at a geopolymer mixture, an ancient form of synthetic stone. Imagine a builder not hauling a 2-ton block, but mixing a slurry in a wooden mold at the construction site, creating a perfect, seamless block exactly where it was needed. This would solve the immense logistical problems of transport and lifting in an elegant, almost shockingly modern way. The theory remains controversial within mainstream Egyptology, but it forces a vital question. Are we sure we know what we are looking at? Is every ancient stone a piece of a mountain, or could some be a sophisticated recipe, a lost formula for artificial rock? Beyond chemistry, there are whispers of another forgotten science, one of sound and vibration. Legends from multiple cultures speak of stones being made to move or to become soft through the use of chants, trumpets, or specific frequencies. While this sounds like pure myth, modern experimental archaeology has shown that certain resonant frequencies can dramatically affect the behavior of granular materials like sand, creating fluid-like patterns. Could a specific sonic vibration reduce friction or temporarily alter the crystalline structure of stone? The idea seems fantastical, yet it offers a potential explanation for the impossible precision of joints where stone fits against stone with no mortar and no gap. Perhaps the final fitting was not achieved by grinding, but by inducing a state where the stones literally flowed together. A compelling, modern parallel to this mystery of manipulation exists in Florida, at a place called the Coral Castle. In the early 20th century, a single man named Edward Leedskalnin, who stood just 5 feet tall and weighed barely 100 pounds, single-handedly quarried, carved, and positioned over 1,000 tons of coral rock. He claimed to have rediscovered the building secrets of the pyramids, and he worked mostly at night, shrouding his methods in secrecy. When asked how he moved the massive blocks, he would only say he understood the laws of weight and leverage. The blocks are precisely fitted, and one 9-ton gate rotates so perfectly on a metal shaft that a child can push it open, yet it remains perfectly balanced. Leedskalnin left no blueprints. His achievement stands as a haunting reminder that an individual with a profound understanding of principles we may have overlooked can accomplish what machinery suggests is impossible. He forces us to ask, if one man in the 1900s could do this with claimed ancient knowledge, what might an entire civilization, with that knowledge fully developed and integrated, have been capable of? The stones themselves may be trying to tell us their secret, not through their weight but through their altered and perhaps intentionally engineered nature. The Coral Castle stands as a modern echo of a much older truth, that precision is the silent signature of advanced knowledge. This brings us to the third, and perhaps most profound, clue embedded in these ancient sites, a language written not in words but in stone and star. It is the clue of architectural precision and alignment, a level of accuracy that seems to whisper of tools and techniques far beyond the simple plumb bob and rope. Consider the Great Pyramid of Giza. Its 4 base sides are aligned to the cardinal points north, south, east, and west with an error of less than 1/15th of a single degree. To achieve that today, you would need a theodolite, a clear view of the pole star, and sophisticated calculations to account for atmospheric refraction. The builders did it on a scale of acres, with a margin of error that is almost negligible. Furthermore, the pyramid's dimensions encode mathematical constants like pi and the golden ratio, not as crude approximations, but embedded within its very proportions. This is not likely to be an accident of primitive measurement. It suggests an intent, a deliberate encoding of cosmic and mathematical principles into architecture. This pattern of celestial conversation repeats across the globe. Stonehenge in England is a massive astronomical calculator, its heel stone marking the summer solstice sunrise. Machu Picchu in Peru is oriented with breathtaking precision to the solar alignments of the equinoxes and the surrounding sacred mountains. Historian Graham Hancock has long argued that these alignments are not merely ceremonial, but are the fingerprints of a lost civilization with a sophisticated understanding of precession, the slow wobble of the Earth's axis over a 26,000-year cycle. He suggests these sites were built as a kind of message in stone, a warning or a legacy meant to survive global cataclysms, pointing to specific dates in the distant past and future. Whether one agrees with that theory or not, the alignments themselves are undeniable facts. They required generations of precise astronomical observation, a coherent system of knowledge passed down, and the technical ability to translate that knowledge into multi-ton stone monuments placed with unwavering accuracy. How was this surveying done? The conventional tools of the era, like the groma or merk-hit used in Egypt, could achieve good accuracy, but the perfection seen in the largest projects pushes the limits of what those tools are believed to be capable of. This leads to a fascinating question about the nature of the technology. Could it have been energy-based or harmonic? Some researchers point to the curious acoustic properties of sites like the King's Chamber in the Great Pyramid, which resonates at a specific frequency, or the way certain stone chambers in Malta amplify sound in strange ways? Was there an understanding that vibration could be used not just to potentially soften stone, but to align it, to sense true level through harmonic resonance? The precision we see hints at a system where architecture, astronomy, and an intimate knowledge of Earth's own energies were not separate sciences, but parts of a unified technology. The stones were placed not just where they looked good, but where they felt right, where they resonated with the landscape and the cosmos. This level of integration suggests a purpose far beyond mere tomb building or simple worship. It points to a civilization that saw its structures as active components of the living world, tuned like instruments to a frequency we have long since forgotten how to hear. So we must ask, was this incredible precision merely an artistic flourish, or was it the functional requirement of a technology we no longer understand? If the latter is true, then we are not just looking at ruins, we are looking at the dormant machinery of a lost science. Precision on that scale speaks a language of intent, and sometimes the clearest translations of that intent come from the stories the builders left behind. When we move from the silent testimony of stone to the whispered hints in ancient texts, we enter a realm where history and myth intertwine. Across cultures, the construction of the most impossible monuments is attributed not to human labor alone, but to the intervention of gods, giants, or magical aids. The ancient Egyptians spoke of the god Thoth, who provided the sacred knowledge of architecture and measurement. The Incan legends tell of Viracocha, a bearded teacher who instructed people in the arts of civilization, including masonry. For a long time, these were dismissed as pure allegory, the human tendency to deify great leaders or explain the unexplainable. But what if we listen to these myths not as fairy tales, but as potential records, metaphors for a sophisticated technology that later generations could no longer comprehend? Comparative mythologists have long noted striking parallels in these stories. They often feature a knowledgeable being who arrives, shares specific arts, and then departs. The tools described are frequently not hammers and chisels, but objects of power. In the Sanskrit epics of India, like the Mahabharata, there are detailed descriptions of vimanas, flying chariots that could travel vast distances and were sometimes used in warfare. Mainstream scholarship interprets these as poetic imagination or later additions, but the sheer technical specificity in some passages gives pause. They describe shapes, materials, propulsion sounds, and even flight patterns. Could these be garbled accounts of advanced machinery, remembered long after the knowledge to build it was lost? Another fascinating example comes from Jewish legend, referenced in the Talmud, of the Shamir. This was said to be a tiny creature or stone, possibly a worm, that could cut through any rock with a mere touch. King Solomon supposedly used it to build the first temple in Jerusalem, as iron tools were forbidden for working the sacred stone. This story, while magical, points directly to the core mystery we see in places like Pumapunku in Bolivia, where andesite blocks are cut with laser-like precision and drilled with perfect cylindrical holes. The legend of the Shamir seems to encode a desire for a technology that could shape stone without brute force, without the profanity of metal striking rock. It imagines a process that is clean, precise, and almost organic. Similarly, the ancient Greek writer Herodotus recorded that the Great Pyramid was built using machines made of short wooden planks. Egyptologists generally believe he was describing levers, but his account is vague and comes millennia after the fact. Could his source have been referring to something more complex, a system of counterweights or harmonic devices that later eras simply had no framework to understand? When a culture loses a technology, the memory of it doesn't vanish, it transforms. It becomes myth. The god who moves mountains becomes a metaphor for the crane that the people no longer possess. The magical chant that softens stone becomes the folk memory of a resonant frequency used in construction. These stories are the cultural echo of a real event, stretched and refracted over centuries of retelling. They are not blueprints, but they are clues, persistent hints that the people who came after these megalithic builders were just as baffled by their achievements as we are. They looked at a 1,000-ton block perfectly seated in a temple wall and could only explain it by saying, "The gods must have done it." This interpretive leap from technology to mythology forces a humbling perspective. It suggests that our own modern insistence on seeing the past through the lens of simple tools might be its own kind of myth, a story we tell ourselves because the alternative, that an entire branch of human engineering knowledge has vanished, is a deeply unsettling idea. It challenges our linear view of progress, so we are left with a landscape of stone and a library of story, both pointing toward a capability that seems to slip just beyond our grasp. If the myths preserve a kernel of truth, then what was the real nature of the technology they describe? And more importantly, what could have caused such a profound and widespread forgetting? The transition from myth to tangible physics brings us to the most ethereal clue, one that resonates not in stone but in the air itself. This is the theory of sound and vibration as a lost technology. Picture, if you will, a construction site not of grunting laborers and pounding hammers, but of focused chanters and humming stones. The idea that specific acoustic frequencies could alter the physical properties of matter sounds like pure fantasy, yet it is a thread woven through both ancient legend and modern laboratory experiments. Consider the legends of Tibetan monks, who are said to have used long trumpets and deep chants to levitate stones onto mountain ledges during the construction of remote monasteries. Similar stories echo from the builders of the Coral Castle, where Edward Leedskalnin spoke of understanding the laws of magnetism and vibration. These accounts are often dismissed as folklore, but they point toward a persistent human intuition that sound holds a power we have yet to fully master. Modern researchers are beginning to take this intuition seriously. Scientists like John Stuart Reid have dedicated years to studying cymatics, the visible patterns that sound waves create in materials like sand or water. When specific frequencies are applied, these inert substances organize themselves into intricate geometric shapes, demonstrating that vibration directly influences physical structure. Reid and others have extended this research to stone, exploring how resonant frequencies might affect the crystalline lattice of granite or limestone. The theory suggests that every object has a natural resonant frequency, a pitch at which it vibrates most freely. If you could match that frequency precisely and amplify it, you might induce a state of acoustic levitation or, more plausibly, dramatically reduce internal friction. In this resonant state, a massive block might behave less like a rigid solid and more like a viscous fluid, allowing it to be moved or shaped with surprising ease. Physicists who study granular materials confirm that vibration can cause them to act like liquids, a principle used in modern industry to move powders and grains. Scaling this effect up to multi-ton stone blocks is a monumental leap, but not an impossible one from a physics standpoint. It would require an incredible control over frequency and amplitude, perhaps achieved through large, tuned instruments or precisely coordinated human voices. This acoustic approach reframes the entire problem. Instead of asking how they pushed a 1,000-ton block, we might ask how they convinced it to float or to become momentarily weightless. It offers an elegant solution that leaves no tool marks, requires no massive ramps, and explains the impossible precision of fittings, as stones tuned to the same frequency might literally flow together. This idea moves the technology from the realm of brute force into the realm of applied knowledge, a harmony between the builder and the built. It suggests a civilization that understood the universe not as a collection of separate objects, but as a symphony of vibrations, where every mountain, every stone, and every human voice was part of a single manipulable song. So we must wonder, were the grand temples and pyramids not just silent tombs, but instruments themselves, designed to resonate with the earth and the heavens? If the stones could sing, what forgotten melody made them move? The idea of stones moved by sound feels like magic, but what if the true technology was far more elemental, a mastery of the most abundant force on our planet? Water, its power is quiet, relentless, and possesses a property that directly confronts our core problem, buoyancy. A 1,000-ton stone is immovable on land, but suspended in water, it loses most of its effective weight. This simple principle leads us to the sixth and perhaps most practical clue, a forgotten chapter in ancient hydraulic engineering. Imagine not a dusty desert hall, but a stone of epic proportions floating serenely on a canal, guided by the gentle current of a seasonal flood. This is not pure speculation. At the temple complex of Ollantaytambo in Peru, high in the Andes, we find massive red granite blocks quarried from a mountainside 6 miles away across a deep river valley. The conventional theory of dragging them up one slope and down another seems almost absurd given the terrain. Yet, researchers like archaeologist Jean-Pierre Protzen have noted the presence of ancient, sophisticated terracing and water channels throughout the sacred valley. Could the builders have created a temporary canal system, using diverted river water to float these blocks across the valley floor during the rainy season? The physics is sound. Water reduces friction to almost nothing. A stone that would require the pulling force of thousands of men on land might be moved by a few dozen with ropes from a barge once it is afloat. The real engineering challenge shifts from moving weight to managing water, from brute force to brilliant logistics. We see hints of this at Giza. While the famous pyramid building ramps get most of the attention, there is compelling evidence, including sediment cores, that suggests an ancient harbor or canal system once reached right to the base of the plateau. The historian Herodotus wrote of machines used to lift stones from one level to the next. But what if those machines were not cranes but locks, a series of water-filled chambers that could raise or lower a floating barge and its colossal cargo step by step? This concept of hydraulic lifting finds a stunning parallel in much later history from Song Dynasty China. In the 11th century, engineers constructed massive floating dry docks called shiplifts. They would guide vessels into a sealed wooden chamber, then use a system of sluice gates to fill or drain the chamber, raising or lowering the ship as needed. This is precisely the technology that could move a megalith, not by lifting it into the air, but by letting water do the work of elevation. The stones at Baalbek present an even more tantalizing possibility. Some researchers propose that the largest blocks were not dragged from the quarry a mile away, but were instead maneuvered during catastrophic seasonal floods. By constructing temporary earthen dams and directing the floodwaters, they could have created a shallow lake that turned the landscape into a temporary waterway. The block would be quarried, then floated directly to its construction site on a rising tide of human ingenuity. Once in position, the water would be slowly drained, leaving the stone settled perfectly into its prepared foundation. This method explains the lack of drag marks or crushed roadways we might expect from a ground transport. It transforms an impossible haul into a manageable, albeit monumental, feat of civil engineering. It highlights a form of technology that is invisible once the job is done, leaving behind only the finished stone and perhaps the ghost of a canal long since filled with silt. This clue reframes the ancient master builders not as wizards of forgotten energy, but as the world's first great hydraulic engineers. They understood the land's contours, the rhythms of the floods, and the profound power of working with nature rather than against it. They didn't fight the weight of the stone, they invited water to negate it. So we are left to ponder, were the greatest monuments of antiquity not just built on land, but delivered by liquid highways we can no longer see? If water was their primary tool, then every massive stone is a testament to a civilization that could make rivers obey and turn the very landscape into a machine. Water's buoyancy is a silent force, but the principle of balance is one we can feel in our own bodies. Stand on a seesaw, and a small child on the far end can lift you with ease. This simple act of leverage is our seventh clue, a mechanical secret hiding in plain sight. The ancients may not have had steel cranes, but they understood the laws of torque and equilibrium with an intimacy we have since outsourced to machinery. This is the technology of the counterweight, a concept that could transform the impossible lift into a manageable, rhythmic operation. Envision not 1,000 men straining against ropes, but a single team carefully adding sandbags to a giant wooden arm, using the Earth's own gravity as their engine. The evidence for such machines in the deepest antiquity is circumstantial, but the principles were undeniably known. In ancient Egypt, the shadoof was a ubiquitous tool, a long pole with a bucket on one end and a counterweight on the other, used for irrigation. It is a perfect, small-scale demonstration of mechanical advantage. Scaling this idea up creates something resembling a crane. The Romans later perfected the trispastos, a wooden crane powered by a human treadwheel that could lift several tons. But could a Roman-style crane lift a 1,000-ton block? Almost certainly not with its materials. The wood would splinter, the ropes would snap. This is where ingenuity meets scale. Mechanical historians like those studying medieval cathedral construction offer a fascinating parallel. To lift the massive stone blocks for towers and spires, builders employed enormous wooden wheels, sometimes turned by teams of men walking inside them like hamsters, to wind thick hemp ropes onto a drum. These devices were marvels of timber engineering, but they still had limits. The leap to megalithic scales requires a different kind of thinking. Perhaps the counterweight system was not a single machine, but the entire landscape. Imagine a stone block positioned at the top of a prepared earthen ramp. Behind it, a vast container is slowly filled with water or sand or smaller stones. As the counterweight container descends down the opposite side of the ramp's crest, it pulls the megalith upward with a smooth, controlled force. This turns the problem from one of pushing to one of managing a controlled descent, a far more efficient use of energy. The key is in the ratio, the mechanical advantage. A counterweight that moves 10 feet down could lift a block 1 foot up if the weight is 10 times greater. By using a system of pulleys or multiple balanced arms in sequence, that advantage could be multiplied. The ancient builders would not have needed our equations, but through trial and observation, they could have mastered the geometry of force. A particularly elegant theory involves the use of the pendulum. A heavy weight, once set swinging, generates a predictable, rhythmic force. Could a series of synchronized pendulums have been used to impart a rocking motion to a massive stone, walking it forward inch by inch with a cumulative momentum that required only small, timed pushes to maintain? This method would leave little archaeological trace, yet it aligns with those oral traditions of statues that walked. It represents a profound understanding of rhythm and inertia, turning a static weight into a dynamic object with a life of its own. So we must ask, did our ancestors see a massive stone not as a dead burden, but as a component in a grand kinetic sculpture where balance was the true architect? The silence of the sites offers no blueprints, but the enduring principles of physics whisper that the tools to move mountains were always here, waiting in the swing of a pendulum and the balance of a lever. The lever and pendulum rely on principles we can see and touch. But what if the greatest force employed was one we cannot see at all, a power flowing through the ground beneath our feet? This leads us to an eighth and deeply speculative clue, the possibility that ancient builders harnessed the Earth's own subtle energies. Beyond water and sound, our planet hums with geothermal heat and shifting magnetic fields. forces that some researchers believe could have been directed by those who understood the land as a living system. Envision a construction site positioned deliberately over a geothermal vent, where the Earth's inner warmth rises to the surface. In cultures from ancient Japan to the Roman Empire, hot springs were sacred sites of healing and community. Could that same geothermal energy have had a practical application? The intense, steady heat from a vent could be focused to thermally stress a stone, expanding it slightly to allow for precise placement, or perhaps even softening certain types of rock to make carving and shaping less laborious. There are accounts, though debated, of cultures using heated stones in ceremonial sweat lodges that would later crack in specific, controlled patterns. This intimate knowledge of heat's effect on stone suggests a foundational understanding that could have been scaled into a technology, but the theory extends beyond simple heat. Some alternative researchers and geomancers point to the curious placement of many megalithic sites along geological fault lines or so-called earth grids, networks of hypothesized energy lines crossing the globe. The Great Pyramid, for instance, sits at a nexus of telluric currents, subtle electrical flows within the Earth's crust. While mainstream geophysics acknowledges these currents exist, their strength is minuscule, hardly enough to power a light bulb, let alone move a mountain. Yet, the persistent alignment of sacred sites with these features is difficult to dismiss as pure coincidence. Could these locations have been chosen because the energy there, however faint, made the work somehow easier, or perhaps because the structures themselves were designed to amplify or interact with that energy? The concept pushes the boundaries of conventional archaeology into the realm of archaeocaustics and geomancy. It invites us to consider a civilization that did not separate science from spirituality, that saw the planet not as an inert resource but as a partner. Building on a ley line or an energy vortex in this view was not mystical superstition but applied planetary engineering. They may have been tuning their monuments to the heartbeat of the Earth itself, creating structures that resonated with natural frequencies to achieve stability, precision, or even purposes we can no longer perceive. This perspective reframes the ancient master builder as a kind of terrestrial conductor, someone who could read the landscape's hidden score and compose in harmony with it. So we must wonder, were these impossible stones not just placed with brute force or clever mechanics, but gently persuaded into position by a civilization that knew how to ask the earth for help? The seamless joints between ancient stones are a language of precision we can barely translate. In the heart of Cusco, Peru, walls built by the Inca showcase blocks of irregular, polygonal granite that lock together so perfectly you cannot slip a piece of paper between them. This is not mortar holding them, it is a three-dimensional puzzle cut with breathtaking accuracy. The puzzle of how they achieved this fit with simple tools forms our ninth and perhaps most tactile clue, a testament to a craft that merged geometry with an intimate feel for stone. The conventional explanation involves a technique known as knobbing. Stonemasons would carve a series of small protrusions or knobs on one face of a block. They would then repeatedly place this block against its neighbor, using a colored paste to mark the high points where the two stones touched. Over countless iterations, they would grind down these high points with stone hammers and abrasive sand, slowly, patiently, achieving a perfect negative impression. It is a method of incredible skill and even more incredible patience, a dialogue between mason and material that could take months for a single joint. For softer stones like limestone, evidence suggests the use of copper saws, but copper is a soft metal, it cannot cut granite. The secret was in the abrasive. By adding a slurry of quartz sand or crushed emery between the copper blade and the stone, the saw essentially became a vehicle for millions of tiny, harder particles to do the cutting. It is a slow, steady process, but it works, leaving behind the distinctive parallel striations we see on some cut surfaces. Yet, some joints and some stone types push even these methods to their limit. The andesite blocks at Pumapunku in Bolivia feature not just flat joints, but complex geometric channels, precise right angles, and drilled holes that are perfectly cylindrical and smooth. To a modern stonemason, these features suggest something beyond pounding and abrasion. This has led to more exotic theories. Could the builders have used plant-based acids to soften the stone surface temporarily? Certain plants, like the sorrel found in the Andes, contain oxalic acid which can etch some rock types. Applied as a poultice, it might have made the very surface of the stone more malleable for final shaping. Another possibility is precise heat treatment. By applying focused heat, perhaps from a lens or reflected sunlight, and then rapidly cooling the surface with water, thermal shock could cause a thin layer to spoil off, allowing for fine-tuning. The Japanese tradition of rebuilding the eye's grand shrine every 20 years offers a living window into such enduring, meticulous craft. Using hand tools passed down for generations, master carpenters and stonemasons achieve fits so precise that wooden joints lock without a single nail, a philosophy of perfection that mirrors the ancient world's approach. These modern masters speak not just of technique, but of a deep, almost spiritual relationship with their material, knowing its grain, its weaknesses, its soul. This hints at what we may have lost, not just a set of tools, but an entire epistemology of making. The time investment alone is staggering to consider. To shape one multi-ton block with stone hammers and abrasives could take a team of workers an entire year. This implies a social structure that could support such long-term, specialized labor, a society that valued permanent, perfect monuments over quick results. It forces a reflective question: what kind of knowledge is embedded in that slow, hands-on process that our power tools have erased? When you spend a year feeling the stone give way under your hands, you learn things no blueprint can teach. The perfect joints are more than an engineering feat. They are the fossilized imprint of a forgotten conversation between human intention and the bones of the earth. The perfect joint speaks of patience, but the timing of its creation might have been just as crucial. This brings us to a 10th clue, one written not in stone but in the stars themselves. Ancient builders may have used the sky as their ultimate calendar, aligning their most demanding work with celestial events to harness natural forces. This is more than just building temples to face the sunrise. It is about using astronomy as a practical tool for engineering on a colossal scale. The movements of the sun, moon, and stars create predictable rhythms on Earth, rhythms of light, temperature, and most importantly, water. A civilization that could accurately predict the summer solstice could also forecast the annual flooding of a river. This knowledge transforms from ritual into a powerful logistical advantage. Consider the possibility of moving the 1,000-ton stones of Baalbek. Researchers examining the local climate and geography have proposed that the builders might have utilized the intense winter rains. By quarrying the stone during the dry season, they could then construct temporary canals or dams, waiting for the seasonal floods to create a shallow, controlled lake. The massive block, already positioned on a prepared cradle, would float as the waters rose. Guided by ropes from the banks, it could be floated directly to its construction site. Once perfectly positioned, engineers would slowly drain the water, lowering the stone with gentle precision into its final resting place. This entire operation hinges on precise timing, knowing exactly when the rains would come and how high the water would rise. That knowledge comes from generations of astronomical observation. We see this synthesis of sky watching and practical planning in ancient observatories. At Nabta Playa in the Sahara, a site older than Stonehenge, stones were arranged to align with the rising points of key stars, likely marking the coming of the monsoon rains essential for survival in the desert. At Chichen Itza, the Pyramid of El Castillo is designed to cast a shadow of a serpent descending the staircase precisely on the spring and autumn equinoxes. events that would have drawn vast crowds and likely marked the beginning and end of agricultural and construction seasons. Archaeoastronomers, scientists who study how ancient cultures understood the sky, emphasize that this was not mere superstition. It was a highly developed science integrated with daily life. The alignment errors we find in some ancient sites, often fractions of a degree, are not mistakes but often corrections. As the Earth's axis slowly wobbles over centuries, the position of sunrise on the horizon shifts. Some monuments show evidence of being realigned over generations to maintain their accuracy, proving this was a living, maintained science. This celestial timing extends to the most remote sites. On Easter Island, analysis of pollen and soil layers suggests the famous Moai statues were likely transported during specific seasons when the ground was soft from rain, making the arduous journey across the island slightly less formidable. The oral traditions that said the statues walked might encode the optimal time for that walking to occur. This clue reframes ancient technology. It suggests that the greatest tool was not a lever or a chant, but a calendar. The ability to predict a solstice, a flood, or a wet season turned the unpredictable forces of nature into a reliable partner. It allowed builders to schedule their most Herculean tasks for the moment when Earth itself was most willing to help. The stones could only be moved because the builders knew when the river would rise, when the ground would be soft, when the nights would be long enough for work by torchlight. This integration of cosmic rhythm and earthly effort reveals a civilization in profound conversation with its environment, using time itself as a foundational component of their art. Celestial timing reveals a civilization in tune with the universe. Yet some stories suggest they achieved an even deeper mastery, one that seems to defy the most fundamental law of all. Across the world, legends speak of stones that did not need to be hauled or floated, but simply lifted themselves. These are the tales of levitation, the 11th and most speculative clue in our search for lost technology. The 10th century Arab historian Abu al-Hasan Ali al-Masudi wrote of the construction of the Great Pyramid, claiming the builders used magical papyri placed under the stones to make them float through the air, guided by the tapping of a rod. In Tibetan Buddhist tradition, sacred texts describe the use of long trumpets and specific chants to levitate stones during the building of remote monasteries, a practice said to have been witnessed by early European travelers. Similar stories echo from the builders of Nan Madol in Micronesia, where massive basalt logs are said to have been flown through the air by magical means. For centuries, these accounts were dismissed as pure allegory, the human imagination dressing up mundane labor in the clothes of magic. But what if we listen to them differently, not as fantasy, but as a culture's attempt to describe a physical technology they could no longer replicate or fully understand? The core concept they point toward is anti-gravity, the idea of negating or manipulating the force that pins us all to the ground. To modern physics, gravity remains the most mysterious of the fundamental forces. We can describe its effects with exquisite precision, but we do not fully understand its origin. Theoretical physicists explore concepts like gravitational waves, space-time curvature, and quantum gravity, realms where the rules we take for granted begin to bend. In these theoretical spaces, the idea of manipulating local gravity is not entirely forbidden by the laws of physics. It is merely an engineering challenge of unimaginable scale. Some researchers point to curious experiments with diamagnetic materials, substances that create a weak magnetic field in opposition to an applied field. Using powerful magnets, scientists have levitated small objects, even living creatures like frogs, in laboratory settings. This is not anti-gravity in the pure sense, but magnetic repulsion, a demonstration that forces can be arranged to counterweight. Could an ancient civilization have discovered a natural material with profound diamagnetic properties, or a way to induce such a state in stone through vibration or electrical charge? Another avenue is acoustic levitation. Modern labs use precisely tuned sound waves to suspend small droplets of liquid or pieces of foam in mid-air, creating nodes of pressure that act as invisible hands. The step from suspending a water droplet to suspending a 1-ton block is again a chasm of engineering, but the principle exists. It resonates powerfully with those legends of stones moved by chant and trumpet. Perhaps the long trumpets described in Tibetan stories were not musical instruments but precisely tuned devices, sonic tools designed to create a standing wave of sufficient power to reduce the effective weight of a stone, making it manageable for a team to guide. These stories from folklore worldwide form a persistent pattern, a collective memory of a different kind of labor. The key is to approach them not as literal truth, but as potential data. When multiple, disconnected cultures describe a similar phenomenon, stones moving through the air without visible support, it warrants a question beyond dismissal. Were these myths born from nothing, or were they born from observation? What did someone, long ago, actually see that they could only explain as floating stones? This line of inquiry challenges us to separate the wild speculation from the kernel of a radical possibility. It asks us to consider that the deepest lost technology might not have been about applying force, but about understanding how to temporarily remove an object from the grip of gravity itself. It is the most extreme answer to the puzzle of the 1,000-ton block, suggesting that the ancient builders did not fight weight, they simply persuaded it to step aside. This idea, while fringe, completes a spectrum of possibilities from the brutally practical to the seemingly miraculous. It forces a final, humbling reflection. If our ancestors did possess such knowledge, even in a nascent form, its loss would represent not just a forgotten chapter in engineering, but a fundamental shift in humanity's relationship with the fabric of reality. What does it mean for our story if the pinnacle of their achievement was not in moving mountains, but in momentarily convincing them to fly? The legends of levitation, however fantastical, all share a common foundation: the coordinated effort of people. A 1,000-ton stone does not move by magic or machine alone. It moves because a civilization decided it must and possessed the social machinery to make it happen. This brings us to a 12th profoundly human clue: the invisible architecture of society itself. The true technology might not have been in the lever or the chant, but in the ability to organize, motivate, and sustain thousands of individuals toward a single, monumental goal. Imagine the scene not as silent magic, but as a symphony of human effort. Teams of workers, their hands on thick hemp ropes, strain in unison, guided by the rhythmic beat of a drum and the calls of a foreman. This is a technology of coordination, a logistics of belief and labor that transformed human muscle into a geological force. We see this system in the records of ancient Egypt. The pyramids were not built by slaves under the lash, as Hollywood often portrays, but by a rotating workforce of skilled laborers, farmers who worked during the Nile's inundation when their fields were underwater. This was a form of corvée labor, a civic duty owed to the state and the gods, and in return, workers were housed, fed, and given medical care in purpose-built villages like the one discovered at Giza. Archaeologists have uncovered bakeries, breweries, and fish processing sites that could feed thousands, a testament to a supply chain as impressive as the construction itself. Similarly, the Inca Empire operated the mita system, a rotational labor tax where communities contributed workers for state projects, from building terraces to erecting the magnificent walls of Sacsayhuaman. This was not mere coercion, it was embedded in a reciprocal world, where labor for the state and the sun god Intai reinforced social bonds and ensured cosmic order. Anthropologists who study these systems point to the power of shared belief and communal identity. Moving a megalith was not just a construction job, it was a religious act, a collective endeavor that strengthened social cohesion and demonstrated the power and piety of the community and its leader. The project itself became the glue that held society together. To understand the scale, let's consider Stonehenge. The smaller blue stones, each weighing up to 4 tons, were quarried in the Preseli Hills of Wales, over 140 miles away. The current leading theory suggests they were transported partway by water, then hauled overland on wooden rollers by teams of people. Estimates suggest moving just one of these stones would have required the coordinated effort of well over 100 individuals for months. The larger sarsen stones, weighing up to 50 tons, were moved from quarries 20 miles away. The entire project, spanning generations, required a stable society with surplus food, clear leadership, and a shared purpose so compelling it justified decades of backbreaking labor. This social technology solves a paradox. How do you get people to commit to a task whose completion they may never see? The answer lies in the project's meaning. Building these monuments was an act of faith, a dialogue with the ancestors and the gods, a way to etch a civilization's identity into the very landscape. The foreman's chants were not just timing beats, they were stories and prayers that connected the daily strain to an eternal purpose. This transforms our view of the ancient builder from a primitive laborer to a participant in a grand, living ritual. The ropes they pulled, the food they ate, the songs they sang, these were all components of a sophisticated social machine. So while we search for lost tools of stone, we must not overlook the most powerful tool of all, the human capacity to organize, believe, and work together across generations for a vision far greater than any single life. The stone that rises is a testament not just to engineering but to the enduring power of a shared dream. A shared dream leaves tangible traces, but what happens when the tools of that dream are made to vanish? Our 13th clue leads us into museum basements and forgotten dig sites where objects sit in drawers, their purpose a mystery. These are the physical echoes of lost technology, artifacts that do not fit the standard narrative, waiting for someone to ask the right question. Among the most famous is the Baghdad Battery, a clay jar dating to the Parthian period, roughly 2,000 years ago. Inside, archaeologists found a copper cylinder and an iron rod, sealed with an asphalt stopper. When filled with an acidic liquid like vinegar, it produces a small electrical charge. Mainstream interpretation suggests it may have been used for electroplating jewelry or for religious rituals, but its true function remains debated. It stands as a quiet testament that ancient peoples may have understood and harnessed principles we assume were discovered much later. Similarly, from the Viking site of Visby, lenses of rock crystal have been found, ground to a quality that suggests they could have been used as magnifying glasses or even as components in simple optical devices. Could these have been part of surveying tools far more precise than we credit? The most ephemeral tools, however, leave no trace at all. Consider the possibility of massive lifting devices constructed from wood, rope, and leather. In a humid climate, these organic materials would rot away within centuries, leaving behind only the stone they moved. A complex system of counterweights and pulleys, a grand wooden crane, could have existed. Its entire form returned to the earth, leaving us with only the impossible result and no blueprint. Archaeologists constantly grapple with this problem of preservation bias. We build our understanding of the past on what survives, primarily stone, pottery, and metal. The sophisticated technology of a culture might have resided in perishable genius, woven into baskets, tied in intricate knots, or carved from hardwood now turned to dust. Even metal tools are often recycled, melted down by later generations for new purposes, effectively erasing the original technology from the record. This forces a profound shift in perspective. The absence of evidence is not evidence of absence. It is an invitation to look more carefully at what remains. Sometimes the clues are not standalone objects, but markings on the stones themselves. The walls of the Hathor Temple at Dendera in Egypt feature a famous series of reliefs. One depicts what some researchers have controversially interpreted as a large light bulb, containing a snake-like filament inside a glass vessel, supported by a pillar and connected by cables to a box held by a priest. Egyptologists explain it as a symbolic representation of a lotus flower spawning a snake, a part of creation mythology involving the god Hapi. Yet, the visual similarity to electrical apparatus is undeniably striking to a modern eye. Is this merely a case of pareidolia, our brains seeing familiar patterns where none exist? Or could it be a stylized depiction of a technology so advanced it could only be described through the symbolic language of the day? The debate itself is valuable, for it highlights how our interpretation of artifacts is filtered through our own cultural lens. We see cables and light bulbs, while an ancient Egyptian might see the cosmic serpent and the Jed pillar. The truth may lie somewhere in between, a sophisticated understanding of energy or illumination expressed through the mythic vocabulary available. This search for tools is not about proving a specific theory, but about maintaining a disciplined curiosity. It asks us to look at a strange object not as an oddity to be shelved, but as a question to be investigated. What if the key to moving a 1,000-ton block was a device made of wood, hemp, and water, a machine that left no fossil? What if the precision cuts on granite were made not with copper saws, but with a lost abrasive compound or a focused beam of sunlight amplified through crystal lenses? Every unexplained artifact is a piece of a puzzle we have not yet fully assembled. The ongoing exploration in this field is fueled by this very possibility that somewhere in a storage room or still buried in the sand lies a piece of the ancient toolkit that will force us to rewrite the story of human ingenuity. The stones were moved, that much is certain. The hands that moved them must have held something we have yet to fully recognize. The tools may have been perishable, but the landscape itself was a permanent partner in the work. Our 14th clue asks us to see the ancient world not as it is today, but as it was, a planet whose face has been reshaped by time and climate. The environment our ancestors built within was a dynamic force, one they learned to harness with brilliant ingenuity. This is the technology of adaptation, using the Earth's own changing moods as a construction aid. Geological studies now paint a picture of a different planet during the peak of many megalithic constructions. Where deserts now stretch, there were once seasonal rivers and lush grasslands. Where silent valleys lie, there once roared glacial ice. This shift in perspective transforms an impossible haul into a manageable journey with nature's help. Consider the Moai of Easter Island. The dominant theory today suggests these massive statues were transported upright in a rocking motion, walked by teams using ropes. But this method requires a prepared track, a smooth, firm road. Pollen analysis reveals the island was once covered in a now vanished palm forest. The fallen trunks of these trees could have provided the perfect lubricated tracks, a natural conveyor belt of wood laid down by the environment itself. The builders didn't just move the Moai, they used the very substance of their homeland to do it, a sustainable technology that disappeared when the forests did. This principle of the helpful landscape extends to colder climates. In parts of ancient Britain and Scandinavia, researchers are examining whether glacial ice sheets, remnants of the last ice age, could have served as natural slipways. A massive stone placed on a sled at the edge of a slow-moving glacier could, over seasons, be carried dozens of miles with minimal human effort, deposited near its intended site as the ice retreated. It is a method that requires patience and precise timing, aligning human ambition with the geological clock. Perhaps the most compelling environmental clue involves water, not as a hauled resource, but as a pre-existing highway. Paleoclimatologists, scientists who study ancient climates, use data from ice cores and soil layers to reconstruct past weather patterns. Their work suggests that periods of intense megalithic building often coincided with eras of significantly wetter climate. The Sahara Desert, for instance, was a greener, savanna-like environment with interconnected lakes and rivers several thousand years ago. This radically changes the logistics for sites like the Nabta Playa stone circle or even the Egyptian pyramids. Stones could have been quarried near now dry riverbeds and floated on seasonal floods for much of their journey, turning a desert trek into a riverine voyage. This idea finds a controversial but fascinating echo in the theory of water erosion on the Great Sphinx of Giza. Geologist Robert Schoch and others have noted what appears to be vertical, rolling erosion patterns on the Sphinx enclosure, patterns typically caused by prolonged, heavy rainfall, not wind and sand. If correct, this would suggest the Sphinx is far older than traditionally dated, carved during a time when the Giza Plateau experienced a much wetter climate. While hotly debated within Egyptology, the theory underscores a vital point: our ancestors built within a world of abundant water that has since vanished. They positioned their monuments not just for celestial alignment but for hydrological advantage. A quarry could be a lakeside dock, a transport route could be a floodplain. This environmental intelligence represents a profound form of technology. It required deep observational knowledge passed down through generations, an understanding of seasonal patterns, river behaviors, and soil conditions. They were not just builders, they were expert readers of their world, turning every natural feature into a potential tool. The drying of a river or the retreat of a glacier didn't just change the scenery, it may have erased the very methods that made their greatest works possible. So we are left to wonder how many of these monumental sites are not where the builders finished, but precisely where the ancient environment, now gone, delivered the stones. A world of interconnected waterways and shifting climates suggests our ancestors were far more mobile than we once believed. This mobility leads us to a 15th and profoundly unifying clue: the web of cross-cultural connections that may have linked distant civilizations, allowing the secrets of megalithic construction to travel across continents. When you stand before the stepped pyramids of Mesoamerica and then look at the smooth-sided pyramids of Egypt, the immediate differences are obvious. Yet the underlying impulse, the drive to build monumental, geometric mountains reaching for the heavens, echoes across oceans and millennia. These parallels force a compelling question: were these similar ideas born independently from a shared human instinct, or could there have been threads of contact, a slow diffusion of knowledge along ancient trade routes we are only beginning to map? The evidence for such contact is fragmentary but persistent. Archaeologists have documented the transfer of plants long before Columbus, such as the presence of sweet potatoes from South America in Polynesia, and tobacco and coca traces in ancient Egyptian mummies, though the latter findings are hotly debated. These biological clues hint at pathways of exchange that could have carried more than just crops. They could have carried concepts. Linguistic parallels also intrigue researchers, with some noting similarities between certain words in ancient Egyptian and Mayan languages for concepts like pyramid or star, though mainstream linguistics largely attributes these to coincidence. The most dramatic evidence comes from the sea itself. Pioneering explorers like Thor Heyerdahl dared to test the possibility of ancient transoceanic voyages with hands-on experiments. In 1947, he and his crew constructed a balsa wood raft, the Kon-Tiki, using only materials and designs available to pre-Columbian South Americans. They sailed it from Peru across the Pacific to Polynesia, proving that such journeys were not just possible but plausible with the technology of the time. Later, with a reed boat Ra-2, he demonstrated that ancient Egyptians could have crossed the Atlantic. Heyerdahl's work did not prove such contact happened, but it shattered the assumption that it was impossible, opening the door to a more interconnected view of the ancient world. When we look closer at the stones themselves, the connections become architectural. Consider the use of polygonal masonry, stones cut into irregular, interlocking shapes. We see it in the foundations of Inca walls in Peru and in the Cyclopean walls of Mycenae in Greece. The technique solves a key engineering problem, earthquake resistance, by creating a flexible, shifting wall that moves as a unit during tremors. Did this brilliant solution arise separately in seismic zones, or did it spread from a common source of architectural wisdom? The corbelled arch, where stones are layered inward until they meet at a peak, appears in the tombs of Mycenae, the Maya buildings of Central America, and the Neolithic structures of Ireland. It is a logical solution to spanning a space without a true arch, but its global presence is striking. Even the concept of aligning structures with celestial events, a hallmark of sacred architecture from Stonehenge to the Sun Temple at Machu Picchu, suggests a shared preoccupation with anchoring human achievement to the cosmos. This interconnected view does not necessarily demand a single, lost super-civilization, though some researchers entertain that idea. It could instead point to a vast, slow-moving network of exchange, a kind of ancient internet where ideas traveled with traders, migrants, and explorers over centuries. A master stonemason from one culture, journeying with a caravan, might share a technique for fitting stones that then evolves over generations in a new land. A story about a flood used to move stones might be told and retold, inspiring a different culture to try a similar method with their own rivers. This transforms the mystery from a series of isolated puzzles into a global conversation in stone. It asks us to see ancient humanity not as scattered, isolated tribes, but as participants in a long, slow dialogue of innovation. The similarities we see may be the fossilized echoes of that dialogue, hints of a shared journey toward understanding our place in the universe. So we must reflect, does the repetition of the pyramid form speak to a universal human archetype, or is it the signature of a technology that once belonged to the world? That global conversation in stone may have been conducted in a language deeper than words. The 16th clue asks us to listen to the silence within the ritual, to consider the role of consciousness itself as a component of ancient technology. This is not about magic spells, but about the potential for focused human intention to influence both the social and physical dimensions of a monumental task. In many esoteric traditions, from Eastern philosophies to Western mystery schools, there exists a persistent idea that matter is not inert, but responsive to consciousness. Applied to our mystery, this suggests that the act of building was not separate from spiritual practice. It was its highest expression. The rhythmic chant of workers pulling a rope was not just for timing, it was a way to synchronize breath, muscle, and mind, creating a unified field of effort that transcended individual fatigue. Anthropologists studying communal labor in traditional societies note that songs and chants are universal, not merely for morale, but to entrain the nervous systems of the group, aligning them into a single, more efficient organism. This synchronization could reduce errors, prevent accidents, and sustain energy levels that would be impossible for a disorganized crowd. Think of rowers in a racing shell, moving as one through shared rhythm, their boat gliding with a power greater than the sum of its parts. The ancient construction site might have operated on a similar principle, but at a monumental scale where the shared rhythm was woven into prayers and invocations. This leads to a fascinating realm of modern research into group consciousness. Studies in fields like transpersonal psychology have explored whether focused group meditation can produce measurable effects in the physical world, with some experiments suggesting potential influences on random event generators or even local environmental conditions. While highly controversial and far from proven, this research asks a profound question about the nature of human attention. Could a collective, ritually maintained state of focused intention have subtly altered the work environment, reducing friction or enhancing precision in ways we cannot yet quantify with our instruments. We see echoes of this fusion in the building of Europe's Gothic cathedrals. These soaring stone forests were not just engineering projects, they were acts of devotion. The master masons operated within secretive guilds, their knowledge imbued with mystical symbolism and sacred geometry. The layout of a cathedral was a map of the cosmos, and every cut of the chisel was a prayer in stone. The workers were not laborers in a modern sense, they were participants in a grand spiritual endeavor. This shared sacred purpose likely fostered a quality of attention and care that transcended ordinary craftsmanship. It created a culture where the line between technical skill and spiritual discipline was blurred. This idea touches on the well-documented placebo effect, where belief alone can produce real physiological changes, such as reduced pain or accelerated healing. If belief can so powerfully affect an individual's body, could a shared, culturally reinforced belief system affect the behavior of materials or the flow of a project? Some researchers in frontier science theorize about psychokinesis, the direct influence of mind on matter. While mainstream science remains deeply skeptical, the theoretical possibility exists within interpretations of quantum physics, where the observer is understood to influence the system being observed. At the scale of a 1,000-ton block, this seems negligible, but what if the observer was not one person but 10,000, all holding a unified vision of the stone's perfect placement? This clue ultimately asks us to expand our definition of a tool. We readily accept that a lever is a tool that amplifies force. But what if a ritual chant is a tool that amplifies coordination? What if a shared meditative state is a tool that refines perception and patience? In a world where spirit and matter are not separate, the most advanced technology might have been the trained human mind itself, capable of entering states of heightened awareness and collective focus that we, in our fragmented modern world, can scarcely imagine. The perfect joint, then, is not just a meeting of two stones, but a meeting of intention and material, a moment where the builder's consciousness left its quiet, indelible mark. The quiet collaboration between mind and material might have been guided by a silent, universal language. 17th clue, the mathematical codes in stone. Across the ancient world, from the plains of Salisbury to the Giza Plateau, builders embedded complex numerical relationships into their monuments, relationships that mirror the fundamental constants of our universe. This is not about simple counting, but about a sophisticated technology of measurement and proportion, a hidden syntax written in length, width, and angle. The stones themselves seem to whisper equations we only formally discovered millennia later. The most famous example is, of course, the Great Pyramid. Its base perimeter, divided by twice its height, gives a figure extraordinarily close to pi, the ratio of a circle's circumference to its diameter. This mathematical constant, crucial to geometry and astronomy, appears encoded in its very shape. Furthermore, the pyramid's dimensions incorporate the golden ratio, approximately 1.618, a proportion found throughout nature in spiraling shells and branching trees, a number often associated with aesthetic harmony and growth. To mainstream Egyptology, these incorporations could be the result of a chosen architectural slope combined with a convenient unit of measurement, the royal cubit. Yet, the precision with which these constants emerge from the simple act of laying out a square base and a chosen angle is striking enough to make mathematicians pause. It suggests an intent, a desire to bind human creation to cosmic order. This pattern extends far beyond Egypt. At Stonehenge, the arrangement of stones and holes reflects Pythagorean triples, right-angled triangles with whole number sides, centuries before Pythagoras was born. The massive stone rose at Karnak in France. Thousands of men, here stretching for miles, appear to have been laid out using a precise unit of measure now called the megalithic yard, about 2.72 of our modern feet. Surveyor Alexander Thom spent decades meticulously studying hundreds of European stone circles, concluding that this standard unit was used with remarkable consistency across vast distances and centuries. His work, while debated, points to a shared system of geometry and astronomy, a common technical language among the megalith builders. What were these codes for? Were they deliberate blueprints from a lost advanced civilization, or simply the beautiful, emergent properties of a culture deeply attuned to geometric harmony? Mathematicians who study these sites often note that the precision is too consistent to be purely accidental. It speaks of a design philosophy where number was sacred, where the act of building was a form of incarnating cosmic truth. The tools for this were not calculators but ropes and stakes, used in a practice known as sacred geometry. By creating specific right angles with a knotted rope in a 3-4-5 triangle, or by swinging arcs from fixed points, ancient surveyors could generate complex shapes and alignments with simple, reproducible methods. The codes, then, may be the footprint of their process. The pyramid's pi ratio could emerge naturally from a builder who decided to make the height relate to the perimeter in the same way a circle's radius relates to its circumference, perhaps symbolizing the squaring of the circle, a potent ancient metaphor for unifying earthly and celestial realms. This mathematical layer transforms our view of the technology. It suggests the greatest tool was not a physical instrument, but an idea, a system of relationships. The monument was not just a building, it was a three-dimensional theorem, a permanent expression of a civilization's understanding of the numerical fabric of reality. To move a 1,000-ton block is one thing, but to place it as part of a grand equation that speaks of stars and spirals is something else entirely. It implies a purpose that transcends the monumental, aiming instead for the eternal. So we must ask, were these ancient sites primarily tombs and temples, or were they the world's first textbooks, written in a language of stone and proportion, meant to teach a truth that words could not fully hold? Mathematical codes whisper of a universal language, but perhaps that language is still spoken in quiet corners of the world. The 18th clue asks us to listen to the living voices of tradition, to the stonemasons and builders in remote communities whose hands remember what our history books have forgotten. These are not archaeologists but practitioners whose daily work may hold the faint, persistent echo of ancient methods. In the highlands of Scotland and Ireland, the craft of dry stone walling continues, a tradition of building without mortar that stretches back millennia. The masters of this craft speak of hearting, the careful selection and placement of small stones within the wall's core. This isn't just filler, it's a critical technology for stability, locking the larger stones in place and allowing the entire structure to flex with frost and earth movements without collapsing. The principle is one of balance and interlocking force, a small-scale demonstration of the same physics that keeps a polygonal Inca wall standing through earthquakes. By observing how a modern dry stone waller listens to a rock, feeling its grain and natural cleavage to find its perfect place, we get a glimpse into the mindset of the ancient mason. It is a conversation with material, a technology of intuition and tactile knowledge that no blueprint can fully capture. Travel to the mountains of Yemen, and you find skyscrapers centuries old, built entirely of sun-dried mud brick or adobe. The builders of these towering structures employ a profound understanding of local materials and environmental forces. They design for thermal mass, for wind deflection, and for seismic resilience using recipes and ratios passed from parent to child. An ethnographer working with these communities doesn't just see construction, they see a living library of applied physics, where the technology is embedded in song, story, and the very rhythm of communal work days. This oral transmission is key. On Nias Island in Indonesia, the tradition of moving and erecting megaliths for ceremonial purposes continued into the 20th century. Anthropologists documented the process, a vital window into pre-industrial logistics. The community would quarry a stone using fire setting and water to fracture the rock, a technique known from ancient sites worldwide. To move the massive slab, they used a combination of wooden rollers, levers, and a pulling frame. But the most crucial element was the crowd. Dozens, sometimes hundreds of people would coordinate their pull on long ropes, guided by rhythmic chanting led by a foreman. This synchronized human power, a social technology, was the true engine. The parallels to what might have happened at Stonehenge or Baalbek are direct and powerful. It shows that the movement of megaliths is not necessarily about a single lost machine, but about the masterful organization of collective effort, a technique that survives anywhere people come together to achieve a monumental shared goal. Interviewing a modern master stonemason restoring a Gothic cathedral reveals a similar depth. They will describe how the original medieval builders sometimes intentionally cut stones with a slight belly, so that when set in an arch, the pressure from above would squeeze them into a tighter, more perfect lock. This subtle understanding of compressive force, learned over generations of trial and error, is a form of high-level engineering knowledge carried in practice, not in textbooks. These living traditions offer a crucial corrective to our search. They suggest that the lost, high technology of the ancients may not have been a mysterious energy device, but rather the pinnacle of this kind of embodied communal knowledge, raised to an extraordinary scale and precision. The answers we seek may not be buried in the past alone, but are still being practiced in the weathered hands of a wall builder, in the rhythmic chant of a village raising a beam, in the communal feast that follows a day of shared labor. This clue tells us that the thread of ingenuity was never truly broken, it simply frayed, and its strongest strands are still held by those who work in harmony with material and community. Living traditions connect us to the past, but the ground beneath them holds stories of violent change. A civilization's most ingenious tools, especially those made of wood, rope, or delicate alloys, stand no chance against the planet's raw power. The 19th clue forces us to consider the role of catastrophic events, moments where the Earth itself may have acted as a giant reset button, erasing not just lives but entire libraries of knowledge. Envision a sophisticated workshop for moving megaliths full of wooden cranes, tuned acoustic instruments, and intricate lifting harnesses. Now imagine a colossal earthquake, one that shakes the very mountains. The workshop is pulverized, its fragile contents splintered into dust and buried under landslides. What remains after the tremors cease? Only the sturdiest objects survive, the very stones they were meant to move, now sitting as silent, enigmatic monuments amidst the rubble. The methods are gone, leaving behind only the bewildering results. This is the catastrophic lens, a perspective that suggests we are not looking at primitive beginnings, but at the durable ruins of a more advanced past. Geologists provide crucial context for this idea. By studying ice cores, sediment layers, and patterns of ancient shorelines, they can identify periods of abrupt global upheaval. One of the most discussed is the Younger Dryas period, roughly 12,800 years ago. For over a millennium, the Earth, which was warming after the last ice age, suddenly plunged back into near glacial conditions. The cause is still debated, with leading theories including a shutdown of ocean currents or even a cosmic impact event, where fragments of a comet or asteroid struck the ice sheets, triggering fires, floods, and a dramatic climate shift. This period coincides with the extinction of large animals like mammoths and, significantly, with the proposed timeline for advanced prehistoric cultures suggested by some researchers. The cataclysm would have been a global trauma. Rising sea levels would have swallowed coastal cities and harbors, places where maritime technology and trade networks might have flourished. Vast inland floods, perhaps from the bursting of glacial lakes, could have scoured landscapes clean, burying evidence under hundreds of feet of silt. A sudden change in climate would force surviving populations into a desperate struggle for mere survival, where the high arts of architecture and engineering become irrelevant luxuries. Knowledge that took centuries to accumulate could be lost in a single generation, preserved only in garbled myths of great floods and fires from the sky. This theory of a forgotten reset finds echoes in the puzzling precision of sites like Göbekli Tepe in Turkey, a stunning complex of carved stone pillars built over 11,000 years ago, a time when mainstream history suggests humans were simple hunter-gatherers. Its builders buried their own creation deliberately, perhaps in response to a changing world or a looming threat, sealing their achievement for millennia. Could this be the act of a culture trying to preserve something they knew was about to be lost? The catastrophic lens adds a profound urgency to our search. It means every mysterious megalith is not just a puzzle but a potential survivor. The 1,000-ton stone at Baalbek is not a testament to what those people could do. It might be a fragment of what they routinely did, a single chapter from a manual that was burned. It reframes the question from how did they do this with simple tools to what incredible tools did they possess that were so vulnerable to time and disaster. What if the lost technology wasn't merely forgotten, but was quite literally washed away, buried, or shaken apart? This perspective is both humbling and expansive. It suggests that human history may not be a smooth, upward line, but a series of peaks and deep valleys, with each recovery having to reinvent the wheel from the scattered pieces left behind. We are left to wonder, are we today, in our own technological zenith, building with materials and knowledge that could one day vanish just as completely, leaving only our most massive steel skeletons to baffle a future civilization? The stones that survived cataclysms did so because they were built to last, a testament to an engineering foresight that looked far beyond the moment of construction. The 20th clue lies not in the towering faces of these monuments, but in what lies beneath them, in the silent, unseen world of foundations and stability. Moving a 1,000-ton block is a staggering feat, but placing it so perfectly that it endures for thousands of years through earthquakes, floods, and settling earth is an achievement of a different order. This is the hidden technology of the ground itself, where ancient builders demonstrated a profound understanding of soil mechanics, drainage, and seismic resilience long before these became formal sciences. Consider the mighty trilithon stones at Baalbek. 3 colossal blocks, each weighing around 800 tons, form a wall 60 feet high. Their awe-inspiring presence is matched only by the ingenuity hidden below. Archaeologists have discovered that these giants are not simply resting on flat ground. Their foundations are a masterpiece of preparation. The builders excavated down to the stable bedrock, then created a carefully engineered fill. This involved layers of packed gravel and smaller stones, meticulously leveled. This foundation acts like a modern shock absorber. During an earthquake, the gravel layers can shift and settle slightly, allowing the massive stones above to move as a unit without cracking. It is a flexible joint at a monumental scale, a deliberate design to dissipate energy rather than resist it. Structural engineers who study these sites express a professional admiration for this ancient wisdom. They note that the principles at work, distributing immense point loads over a wider area and allowing for controlled movement, are exactly what modern seismic codes aim to achieve. The ancients arrived at these solutions not through abstract formulas, but through generations of observational learning, understanding how the earth shakes and how stone reacts. This knowledge of soil is evident across the ancient world. The Romans, famed for their aqueducts and roads, were masters of foundation engineering. Before laying a single stone for an aqueduct's towering arches, their engineers would dig deep trenches and fill them with layers of rubble, clay, and mortar, creating a stable platform that could bear immense weight for centuries. They understood that a structure is only as strong as what it sits upon. Similarly, the leveling techniques employed for vast temple platforms, like those at Machu Picchu or the Giza Plateau, reveal a meticulous attention to the horizontal plane. Using simple water-filled trenches as giant spirit levels or long sighting tubes, they achieved a flatness that still baffles surveyors today. This was not just for aesthetics. A perfectly level foundation prevents uneven settling, a primary cause of structural failure. Water management was another critical component of this below-ground technology. In many megalithic sites, you will find intricate networks of drainage channels carved into the bedrock or built from stone. At the base of walls, these channels redirect rainwater and groundwater away from the foundation, preventing erosion and the destructive force of hydrostatic pressure, which can push walls apart from below. The builders knew that water, over time, is a more relentless force than any earthquake. By giving it a clear path to escape, they protected their work from the slow, insidious decay of frost heave and soil liquefaction. This holistic approach reframes the ancient builder as a geotechnical engineer. The challenge was never just the stone above, it was the conversation between that stone and the living earth below. They weren't just placing blocks, they were mediating a relationship, creating a stable marriage between immense mass and a dynamic, shifting ground. The proof of their success is in the timeline. These stones have stood through seismic events that have toppled modern cities. They have weathered climatic shifts that have rewritten coastlines. Their endurance is not an accident, it is the signature of a deep, applied wisdom. So we must ask, in our rush to admire the heights they reached, have we overlooked the profound depth of their understanding? The true genius might be buried, a quiet intelligence holding up the wonder for all to see. That profound understanding of the earth suggests a purpose far greater than simple monumentality. The sheer scale of these projects forces a deeper question: what were these stones truly for? Beyond tombs or temples, could they have been functional machines designed to interact with the very forces of the planet? This 21st clue shifts our focus from the engineering of movement to the engineering of meaning, exploring the radical idea that megaliths were sophisticated devices for harnessing energy, tracking time, or even bridging realms. The most provocative theory comes from engineer Christopher Dunn, who spent decades studying the Great Pyramid not as a tomb, but as a machine. His Giza power plant hypothesis proposes that the pyramid was a giant harmonic resonator designed to convert the Earth's vibrational energy into usable power. He points to the materials, the precise internal geometry, and the strange absence of soot in the so-called air shafts as evidence. In his view, the granite in the king's chamber acted as a piezoelectric generator, vibrating from the Earth's natural frequencies, while the pyramid's shape focused this energy. The purpose was not to honor a king in the afterlife, but to power a civilization. While mainstream Egyptology firmly rejects this idea, it challenges us to listen to the structure differently, to hear it not as a silent tomb but as a dormant engine. This functional perspective finds echoes in other sites. Newgrange in Ireland, a 5,000-year-old passage tomb, is famous for its winter solstice alignment. For a few minutes at dawn around December 21st, a narrow beam of sunlight travels up a long passage and illuminates the central chamber in a dramatic burst of golden light. Archaeologists see this as a profound symbolic rebirth of the sun. But what if the symbolism was a side effect of a precise function? Could that focused beam of light entering a specially constructed light box have been a form of solar energy harvesting or a method of celestial timekeeping so accurate it governed agricultural and ritual cycles? Similarly, the Mayan pyramid of Kukulkan at Chichen Itza is renowned for the serpent of shadow that descends its staircase during the equinoxes. the structure also possesses remarkable acoustic properties. A clap at the base of the stairs produces an echo that resembles the chirp of the sacred Quetzal bird. A shout from the top can be heard with unusual clarity at great distances across the flat plaza. Were these sonic effects accidental byproducts of the architecture, or were they intentionally engineered, turning the pyramid into a giant communication device or an instrument for ritual sound? Cultural historians remind us that for these societies, there was no separation between the spiritual and the practical. A structure that tracked the solstice was both a calendar for planting and a conduit to the divine. A stone that resonated at a certain frequency was both a tool for community ceremony and a way to harmonize with cosmic vibrations. The technology was not separate from the belief system, it was its physical expression. This purpose-driven view fundamentally enriches the mystery. It suggests that the innovative methods for moving and placing these stones were not ends in themselves, but means to a far more complex goal. The form was dictated by a desired function that integrated astronomy, acoustics, and geomancy. The 1,000-ton block was not just a display of power, it was a critical component in a larger system, perhaps chosen for its specific mineral content or its ability to hold a vibrational charge. So we must reflect, did the drive to create a spiritual portal or an energy generator necessitate the invention of technologies we have since mislabeled as impossible? Perhaps the greatest loss is not the method of moving the stone, but the understanding of why it needed to be moved to that exact spot, at that exact angle, to begin with. The purpose behind the stone may remain elusive, but its physical movement is a problem we can test with our own hands. This leads to a 20-second clue, the realm of experimental archaeology, where modern researchers put on work gloves and attempt to recreate the past, not with theories but with ropes, wood, and sweat. These are not thought experiments, they are physical trials that often humiliate modern assumptions and occasionally reveal startling simplicity. The goal is to strip away our technological arrogance and ask, with only the materials of the era, what is actually possible. One of the most famous modern attempts involved the Moai of Easter Island. In the 1980s, a team led by archaeologists Joanne van Tilburg and Charles Love, along with a group of local Rapa Nui volunteers, decided to test the oral tradition that the statues walked. They fashioned a concrete replica of a medium-sized Moai weighing about 10 tons. Using 3 teams with strong ropes tied around the statue's head and base, they developed a rocking technique. One team would pull to tilt the statue forward, while another team on the opposite side would then pull to rock it to the next side. With coordinated effort and rhythmic chants, the concrete Moai began to sway and, inch by inch, walk across the landscape. The experiment was a success, but it was grueling and required immense skill to prevent the statue from toppling. It proved the walking method was feasible, but also highlighted the hidden variables, the need for perfectly coordinated teams and a prepared, level path. The real ancient builders likely possessed a refined, generations-old version of this technique, turning a difficult experiment into a cultural routine. Another ambitious project was undertaken by the Nova television series in their Secrets of Lost Empires series. Teams of engineers, archaeologists, and stonemasons were challenged to solve ancient construction puzzles using period-appropriate technology. In one episode focused on the pyramids, a team attempted to build a small, 20-foot-high pyramid using a straight ramp, a technique long theorized for the Great Pyramid. They quarried limestone blocks using copper saws and abrasive sand, a painfully slow but effective process. The ramp, however, became the true challenge. As they built upward, the ramp needed to grow longer and wider to maintain a gentle slope, consuming a staggering amount of material and labor just to build the construction road itself. The experiment revealed the ramp theory's logistical nightmare, forcing the team to constantly expand their worksite. It didn't disprove ramps for smaller stones, but it cast serious doubt on their practicality for the largest monoliths, suggesting that if ramps were used for the grandest projects, they must have been of a brilliantly efficient design we have not yet envisioned, perhaps a spiraling internal ramp or a system using the pyramid's own core as a structure. Perhaps the most illuminating insights come from the engineers who participate. Mark Whitby, a structural engineer, worked on a NOVA experiment to raise a Stonehenge-sized lintel stone. His team devised a system using a wooden frame, ropes, and a counterweight made of a wicker basket filled with stones. By gradually adding stones to the basket, they slowly raised the multi-ton lintel into place. Whitby's reflection was telling. He noted that the process was less about raw power and more about control, about managing forces with clever geometry. The real revelation was the social component, the need for clear communication and trust among the team pulling the ropes. A failed command could mean a crushed foot or a shattered stone. These experiments consistently show that success hinges on factors rarely discussed in textbooks: the rhythm of the work song, the exact moisture content of the soil for lubrication, the precise angle of a wooden lever. A team in Japan attempting to move a large stone on a sledge found that wet clay was a far more effective lubricant than water alone, reducing the required pulling force by half. A group in Egypt discovered that by tilting a stone slab onto its edge, they could pivot it with surprising ease, a technique that might explain certain tool marks found in quarries. Each experiment, whether a triumph or a failure, adds a data point. They prove that many feats considered impossible are, in fact, achievable with Neolithic toolkits, but only with a degree of skill, patience, and communal organization that we moderns struggle to muster. The trials bring the past to life in a visceral way, transforming silent stones into scenes of shouting, laughter, and shared triumph. They suggest that the lost technology might not be a single secret, but a vast body of tactile knowledge, learned through 10,000 trials and passed from calloused hand to calloused hand, a wisdom that resided in the muscles and instincts of the builders as much as in their minds. The physical trials of experimental archaeology bring a grounded perspective, but they exist within a much larger and often heated intellectual arena. This brings us to the 23rd clue, the vital landscape of controversy and skepticism that surrounds the entire mystery of lost ancient technology. The debate is not a quiet academic footnote. It is a vibrant, sometimes clashing conversation between well-established institutions and bold, independent thinkers, each armed with their own interpretation of the same silent stones. On one side stands the formidable edifice of mainstream archaeology, represented by figures like Egypt's former Minister of Antiquities, Dr. Zahi Hawass. His position is one of immense caution, built upon decades of excavation, peer-reviewed study, and a rigorous methodology. From this viewpoint, the pyramids are understood as the pinnacle of Bronze Age ingenuity, built by a highly organized society using tools we have largely identified: copper chisels, stone pounders, wooden sledges, and earthen ramps. The apparent mysteries, they argue, are gaps in our knowledge, not proof of a forgotten science. They point to the worker villages at Giza, the quarry marks, the experimental successes in moving smaller blocks, as a cumulative case that the conventional story, while incomplete, is fundamentally correct. The critique of alternative theories is often sharp, dismissing claims of lost civilizations or advanced technology as pseudoscience, a romantic overinterpretation that disrespects the genuine and remarkable achievements of ancient peoples. They warn of the dangers of selectively ignoring evidence that doesn't fit a preconceived narrative, of seeing patterns where none exist. A classic example is the so-called Baghdad battery. While it can produce a small charge, most mainstream scholars argue its primary use was likely for electroplating jewelry or held a religious, symbolic purpose, not that it represents widespread electrical technology. They see the quest for a single, global lost civilization as undermining the incredible diversity and independent genius of human cultures worldwide. Opposing this view are researchers like Graham Hancock, who argue that the mainstream paradigm is a fortress protecting an outdated timeline. Hancock and others propose that a sophisticated precursor civilization, what he calls a mother culture, was largely wiped out by a cataclysm like the Younger Dryas impact event around 12,800 years ago. The survivors, he suggests, traveled the globe, seeding knowledge of astronomy, agriculture, and megalithic construction among hunter-gatherer societies. The evidence from the astronomical alignments of Giza to the submerged ruins off the coast of India and Japan points not to isolated genius but to a shared legacy from a common source. This school of thought accuses mainstream archaeology of being dogmatic, of ignoring or dismissing anomalous data like the water erosion, patterns on the Sphinx, or the precise celestial codes in ancient monuments because it threatens a carefully constructed historical narrative. The debate often centers on dating. Mainstream science relies on methods like radiocarbon dating and stratigraphic analysis. Alternative researchers sometimes challenge these results, pointing to potential contamination or arguing that the dating only applies to organic material found at a site, not necessarily to the stonework itself, which could be much older. This creates a fundamental impasse, a clash over the very chronology of human achievement. Historians of science watching this debate see a familiar pattern. Scientific understanding rarely advances in a smooth line. It often proceeds through what philosopher Thomas Kuhn called paradigm shifts, where accumulating anomalies that cannot be explained by the old model eventually force a revolutionary new framework. The current tension around lost ancient technology could be seen as the friction of such a potential shift, where the anomalies, the 1,000-ton stones, and the precise alignments are pressing against the edges of our accepted history. This controversy is not a weakness in the search, but its very engine. It forces everyone, from the tenured professor to the curious viewer, to scrutinize evidence more carefully. It asks us to distinguish between a wild speculation and a legitimate hypothesis. When you look at the interlocking stones of Sacsayhuaman, do you see the result of generations of patient labor with stone hammers, or the fingerprint of a method we have yet to comprehend? The answer may not be a simple choice between one or the other. Perhaps the truth incorporates elements from both sides of the divide, acknowledging the incredible skill and organization of ancient societies while remaining open to the possibility that they possessed pockets of sophisticated, even startling, knowledge that has left only the most durable traces. This balanced, critical engagement is the most important tool of all. It allows us to marvel at the mystery without abandoning reason, to question the official story without embracing fantasy. The stones do not take sides in this debate, they simply endure, waiting for us to ask better questions. The stones may not take sides, but they can still reveal their secrets to those who know how to look. The 24th clue points not to the past, but to the future of discovery, where the very tools of our modern world are becoming the keys to unlocking ancient puzzles. This is the promise of new technologies like LiDAR, or light detection and ranging, and ground-penetrating radar. These are not just fancy gadgets, they are digital shovels allowing us to see through dense jungle canopies and deep into the earth without ever breaking ground. Imagine a vast, uncharted region of the Amazon rainforest. For centuries, it was believed to be a pristine wilderness with only small, scattered tribes. But when archaeologists flew over with LiDAR, they saw something astonishing. The lasers pierced the thick vegetation, revealing the ghostly outlines of vast, geometric earthworks, complex road networks, and what appear to be the remains of sizable settlements. This hidden landscape suggests a previously unknown scale of pre-Columbian civilization, one that could have possessed the social organization and engineering knowledge to undertake large-scale projects. The ground beneath our feet holds similar surprises. Ground-penetrating radar sends pulses of energy into the soil, creating a sonogram of the subsurface. It can detect buried walls, chambers, and even voids, mapping entire cities before a single trench is dug. This technology is revolutionizing sites like Stonehenge, where recent surveys have revealed a sprawling ritual landscape of hundreds of previously unknown monuments, pits, and burial mounds surrounding the famous stone circle. It shows that our iconic view of these places is just a fragment of a much larger, more complex picture. The next frontiers for this technological exploration are as vast as the planet itself. Researchers are using satellite imagery to scan the deserts of Arabia for lost caravan cities, and sonar to map the seafloor for submerged settlements off the coasts of India and Japan, lands that would have been dry during the last ice age. Even the icy frontiers of Antarctica, whose coastline was ice-free thousands of years ago, are being studied through satellite radar that can peer through kilometers of ice to map the bedrock beneath, searching for any sign of human presence from a forgotten epoch when the climate was different. The insights from technologists developing these tools are filled with optimism. They speak of machines that can not only see shapes, but analyze the chemical composition of stone from a distance, or drones that can create three-dimensional models of a ruin in hours instead of years. This acceleration means that in a single generation, we could survey more of the planet's archaeological potential than in all previous centuries combined. This future is not just for professionals. The rise of citizen science and open-source archaeology is democratizing discovery. Online platforms allow anyone with an internet connection to examine satellite imagery for unusual patterns, helping to identify potential sites from the comfort of their home. Crowdsourced funding supports excavations that might otherwise never happen. When the public is engaged as partners in the search, the pool of curious eyes and minds expands exponentially. We have already seen how a single discovery can shatter timelines. Göbekli Tepe in Turkey, with its massive, intricately carved T-shaped pillars, was found by a shepherd who noticed a strange stone. Its excavation forced a profound rewrite of history, proving that complex, monumental architecture existed thousands of years before the invention of agriculture or settled life, according to traditional models. It stands as a powerful reminder that the next groundbreaking find could be just one scan, one satellite pass, or one curious observer away. This forward-looking perspective is ultimately one of hope. For every silent stone that asks a question, there is now a suite of tools being developed to listen for an answer. The mystery of the 1,000-ton block may not be solved by reinterpreting an old text, but by a new machine that shows us the quarry road, the lifting cradle, or the workshop buried beneath the sand. The lost technology may be waiting, not in a forgotten manuscript, but in a data stream ready to be decoded. We are on the cusp of seeing the ancient world with new eyes, and what we find may not just explain how they moved mountains, but fundamentally change the story of who we are. Behind every theory about the stones lies a person driven by a question they cannot ignore. This is the 25th clue, the personal journey of the researcher, a testament to the human spirit of inquiry that often burns brightest outside the walls of established institutions. To understand the search for lost technology, we must also understand the searchers, individuals who have staked their reputations, their careers, and sometimes their peace of mind on a single, compelling idea. Their stories are not just footnotes, they are the very heartbeat of the mystery, reminding us that history is not uncovered by institutions, but by people with the courage to look where others have stopped. Consider the case of Dr. Robert Schoch, a respected geologist from Boston University. In the early 1990s, he was invited to examine the Great Sphinx of Giza, not as an archaeologist, but as a scientist who reads the story of water in stone. His analysis led him to a startling conclusion. The weathering patterns on the Sphinx enclosure were not caused by wind and sand, but by thousands of years of heavy rainfall, a climate Egypt had not experienced since the end of the last ice age. This meant the Sphinx could be far older than its traditional dating of 4,500 years. When Scott presented his findings, the reaction from mainstream Egyptology was swift and severe. He was labeled a pseudo-scientist, his credentials questioned, his theory ridiculed at conferences. Yet, Scott stood by his geological data. He wasn't claiming to know who built it, only that the stone told a story of much greater age. His journey is one of intellectual integrity, of holding firm to observable evidence even when it challenges a deeply held narrative. It highlights the tension that exists when a hard science like geology meets the interpretive field of archaeology, and the personal cost of bridging that divide. Then there are figures like Maureen Clemens, who had no formal background in archaeology at all. Inspired by stories of the Egyptian pyramids, she became fascinated by a simple question: could the massive blocks have been lifted using kites? Her idea seemed outlandish, but she pursued it with relentless passion. She formed a team, consulted engineers, and conducted experiments, eventually succeeding in having a modern crew use a large kite to lift a multi-ton obelisk. While her specific method is not widely accepted as the solution for the pyramids, her story is powerful. It embodies the role of the inspired outsider, the person who approaches an ancient problem with fresh eyes and a willingness to fail publicly. Her work, funded out of pocket and fueled by sheer determination, demonstrates that innovation often comes from the periphery, from those not bound by the rules of a particular field. These personal quests are filled with hardship. Independent researchers often finance their own expeditions, spending years in remote locations with little support. They face the skepticism of peers, the difficulty of accessing restricted sites, and the monumental task of analyzing data without the backing of a university. Yet, the reward is not fame or fortune, but the moment of insight, the piece of the puzzle that clicks into place. An independent researcher might spend a decade mapping a single site in the Peruvian highlands, documenting alignments and stone cuts that no one has studied in detail, driven by the belief that the site holds a key to a larger pattern. Their fieldwork is a solitary dialogue with the past, a slow accumulation of evidence gathered one photograph, one measurement, one sunburned day at a time. Biographies and interviews with these individuals reveal a common thread, an insatiable curiosity that borders on obsession. It is the kind of curiosity that makes someone look at a smooth, vitrified stone wall and ask not what ritual it was for, but what process made it that way. It is the perseverance to follow a hunch for 20 years, to learn a dead language, to master a new scientific technique, all for the chance to answer a single, haunting question. This human element connects us, the audience, directly to the mystery. We are not just learning about stones, we are witnessing the modern echo of the very ingenuity we are studying. The researcher facing ridicule today is not so different from the ancient architect who first proposed moving a 1,000-ton block. Both had to convince others that the impossible was merely the untried. These personal journeys remind us that history is not a closed book, but an ongoing investigation, and that the most important tool in that investigation is not a satellite or a radar, but the stubborn, hopeful, endlessly curious human mind. What would you be willing to sacrifice for a truth only you could see? Perhaps the most profound insight emerges when we stop searching for one lost secret and start listening to the harmony of many. The ancient builders were not limited to a single tool. They were masters of synthesis, weaving together every available strand of knowledge into a cohesive system. This is the power of integration, where sound, water, simple machines, and human spirit became interlocking parts of a single, elegant solution. The lost technology may not have been a forgotten device. but a forgotten way of thinking, a systems approach that viewed the entire landscape as a toolkit. Imagine the final journey of a 1,000-ton block at a site like Baalbek. The process likely began with celestial timing, waiting for the season of heavy rains. Teams would quarry the stone using fire, setting, and water to fracture the bedrock, then shape it with stone pounders and abrasive sand. As the seasonal floods arrived, engineers would open temporary canals, directing the water to create a shallow lake around the quarry. The massive block, positioned on a giant wooden cradle, would begin to float, its effective weight negated by buoyancy. Now the real work of guidance began. Teams on the banks, pulling in unison to rhythmic chants, would steer the floating monolith. The chants did more than coordinate effort. Some researchers suggest specific frequencies could have been used to reduce surface tension in the water or create a more stable vibrational field around the stone, making its movement smoother. As the block neared its destination, the water would be slowly drained through a sluice gate system. But the final few feet of elevation onto the temple platform required a different method. Here, the principles of leverage and the counterweight took over. A frame of timber might be erected, with ropes running through a series of wooden pulleys. The counterweight could be a container steadily filled with water from the same canal system, its gradual descent providing the controlled force to lift the stone the last critical distance into its perfect, waiting slot. This scenario is hypothetical, but it demonstrates how separate technologies, each plausible on its own, become transformative when combined. The water solved the friction problem, the sound solved the coordination problem, and the lever solved the final lift problem. The true innovation was the seamless handoff from one method to the next. This integrated approach reflects a deep understanding of local conditions. In the forested hills of Britain, builders might have relied more on wooden rollers, levers, and the natural slipways of palm trunks. In the desert, they mastered the physics of sand and sledges, perhaps even using wetted clay to create a perfect lubricant. In the mountains, they became geniuses of terracing and gravity, using the land's own slopes to their advantage. They did not force a single solution onto every problem. They observed their environment and adapted their toolkit accordingly. This adaptability is the hallmark of advanced problem solving. Systems thinkers today analyze complex projects by looking at the interactions between components, not just the components themselves. They note that the most resilient systems are often the most integrated, where a failure in one part can be compensated for by another. Ancient engineering projects exhibit this resilience. If a rope snapped during a water-based move, the stone was already partially buoyant, preventing catastrophic collapse. If a counterweight jammed, the stone could be held in place by the very water that floated it. This redundancy and interconnection suggest a sophistication that goes far beyond brute force. We are invited, then, to become co-investigators in this mystery. If you were the chief engineer for a megalithic project, with all the clues we have explored at your disposal, how would you combine them? Would you use acoustic resonance to prepare the stone in the quarry, making it easier to fracture along precise lines? Would you design a series of locking basins to move a stone uphill, floating it from one chamber to the next as you raised the water level? The integration of theories transforms the mystery from a passive puzzle into an active conversation. It empowers us to see the ancient builders not as mysterious aliens or primitive laborers, but as practical geniuses, synthesizing observation, tradition, and innovation. Their greatest legacy may be this very lesson, that the most impossible tasks are often solved not by a single breakthrough, but by the clever, patient integration of many simple truths. The stones that stand today are not monuments to a single secret, but to a symphony of ingenuity where every available tool, from the rhythm of a song to the flow of a river, played its part in the chorus. Our journey through sound, water, and forgotten machines reveals a single, powerful truth. the past is not a ladder we have climbed, leaving simpler minds below. It is a vast, unexplored landscape where cultures we barely understand achieved feats that still command our deepest respect. We have walked through the clues, from the resonant chants that might have softened stone to the brilliant hydraulics that turned floods into forklifts, from the silent leverage of a counterweight to the celestial timing that made the earth itself a willing partner. Each theory, whether grounded in experimental archaeology or soaring into speculative physics, is not a final answer, but a vital piece of a much larger human story. This story challenges the very notion of linear progress. It asks us to consider that advancement is not a straight line forever pointing upward, but a spiral where knowledge can be gained, lost in a cataclysm or a forgotten generation, and then painstakingly rediscovered in a different form. The 1,000-ton stones are permanent questions etched into the planet, reminders that our current technological confidence should be tempered with profound humility. What we dismiss as myth or magic might be the faded memory of a different kind of science, a way of working with the world that we have yet to relearn. The writer Arthur C. Clarke offered a guiding light for mysteries like these. He noted that any sufficiently advanced technology is indistinguishable from magic. To a person from 500 years ago, our smartphones and satellites would be pure sorcery. So when we look at the seamless joints of Pumapunku or the celestial alignment of Giza, we must ask ourselves, are we looking at primitive ritual, or are we looking at the dormant machinery of a technology so advanced, so integrated with its environment, that it has become, to our eyes, a kind of magic? This is not about replacing one dogma with another. It is about embracing a more expansive, more curious view of human potential. It is about honoring the ingenuity of those who came before by taking their achievements seriously, by daring to ask the difficult questions their stones provoke. The search does not end here. Every new scan with LiDAR, every experiment with ropes and rhythm, every fresh look at an old text adds another thread to the tapestry. We are all investigators in this grand mystery, so we turn the question to you. After exploring these clues, what resonates most? Do you see the hand of a master hydraulic engineer in the seasonal floods? Or do you hear the echo of a forgotten harmonic science in the legends of chanting monks? The conversation continues in the comments below. Share your perspective, your own theories on how these stones found their home. And if you are drawn to these enigmas of our shared past, consider subscribing. We are just beginning to scratch the surface of history's greatest puzzles. Thank you for joining this exploration into the unknown, for questioning the stories we have been told, and for looking at the ancient world not as a closed book, but as an invitation to wonder.